All right, I think it's time. Welcome back. I have graded all the tests, so you should be able to check yours out in the grade scope. Please look carefully. I tried my best, but it's actually difficult for me in the grade scope to make sure that I found everybody's questions, because not everybody answered all the questions. I tried my best, but it may be that you answered some question and I didn't see it on one of your pictures, and so I marked down that you skipped that question. So please look it over and make sure that you actually got credit for all the ones that you really did. And if I missed one by accident, let me know and I will find it. All right. I would be happy to chat about the tests. You know, I'm pretty pleased in general with how people are doing as far as finishing the check marks. But if you are becoming concerned, then let me know and I'd be happy to go over stuff or just talk about your progress so far. Anybody have any general questions about the test? Oh, all right, great. Let's continue then. So what we were talking about last time was the Shapley-Shubik. This is a way of measuring the power in a voting system, and most people did great on, there was one Shapley-Shubik question on the test, which people did fine on. So I had one more thing to say about the Shapley-Shubik that will only take about 5 minutes, but didn't quite make it at the end last time, which is where it would have more appropriately gone. But remember the Shapley-Shubik, and then we're going to talk about something different. Shapley-Shubik it is a way of measuring who has the power, and this is about voting permutation, the perms. Remember that? Where it's like if I had, for instance, I'm just going to make up an example here. If I had something like that, and I write down, this is A, B, C, D, and I write down some permutation. For instance, I wrote the numbers in a weird order there. I'm just making this up, so sorry about that. How about like that? And then a voting permutation would be something like C, B, A, D, right? It's like that's one of the perms. There are many perms, but I'm just trying to refresh our memory here. You would write down all the different ways you can order the ABCDs, which would be a lot. And then for each one, you write down the weights sort of in that order. So this would be 4. The C is 4, the B is 6, the A is 8, and the D is 2. And then you decide which one is pivotal. Remember, pivotal means you add these numbers up as you go left to right, and you decide which one actually makes it to the quota or past the quota. Can anybody say in this particular example, which one would it be? Somebody shout it out if you remember how to do it. You add the numbers up as you go. Yeah?
8.
It would be 8. Yeah. I add these numbers from left to right as I go, and I want to decide at which point does it actually make it to 12 or more. And the answer is 4 does not make it. 4 plus 6 is not enough. 4 plus 6 plus 8, that would be 18. That is enough. So the pivotal in this case is the 8, which is A. All right? This is just a little refresher. I hope that you remember how to do the Shapley-Shubik. Most people did this right on the test, and so I suppose those of you don't really have to do the Shapley-Shubik again, but this is how you do it. I had just one more thing to say about the Shapley-Shubik that I wanted to fill in last time but didn't quite make it, and that is, what about dictators and dummies in the Shapley-Shubik? Like, what will actually happen if there is a dictator? Can you predict what the sort of their final Shapley-Shubik score will be? That's the idea. Remember, the final score is something like 3 out of 6 times this person was pivotal. All right. What if there are dictators and dummies in the Shapley-Shubik? So if there is a dictator, let's try and think about if there is a dictator in one of these, which, I mean, in this example there isn't, but what if there was a dictator in one of these things? When you go to decide who will be pivotal, I think, the idea of a dictator is a dictator is the only one whose vote matters at all, right? Their vote will make it all the way to the quota all by themselves, and nobody else can make it to the quota without the dictator. I think what that means is if there is a dictator, the dictator will be pivotal every time, right? They are the only ones who can make it to the quota. And so when you go through all the perms and you decide who is the pivotal one this time, who's the pivotal one this time, it's going to be the dictator every time because they are the only ones who are capable of being pivotal. So if there is a dictator, then the dictator will be pivotal every time. Right? Every time you draw one of those perms, the one that's pivotal will always be the dictator. The dictator will be pivotal every time, and nobody else is ever pivotal. All right? So that means the final answer will basically have 100% Shapley-Shubik to the dictator and then zeros for everybody else because the other ones are never pivotal. The dictator is always pivotal. So the dictator will be pivotal every time. Nobody else is ever pivotal. So the Shapley-Shubik score at the end will be, the dictator gets 100% and all others get 0%. That's how the Shapley-Shubiks will end up if there is a dictator. All right. That was about dictators. Can I just say something about dummies? What about a dummy? If you look at dummies, if there were dummies here, you look at who is pivotal. In the case where one of your voters is a dummy, that would mean they can never be pivotal, right? The pivotal is the person who actually makes it reach the quota. But a dummy is someone who is not capable of ever having any impact on the quota at all. So we can say a similar thing. If there is a dictator, then it looks like this. If there is a dummy, then their Shapley-Shubik score will be 0%. All right. That's all you can say. About everybody else, maybe somebody else could be not 0. But if there is a dummy, they're going to be a 0 for the Shapley-Shubik. All right. And here concludes what I wanted to say about the Shapley-Shubik, but didn't quite make it in last time. All right. This is very simple. I hope you agree with me. In the Shapley-Shubik, if there's a dictator, they're going to have 100% for their score. And if there's a dummy, it's going to be 0. Anybody got thoughts about this? All right, that's what I wanted to say. We have one more topic concerning the weighted voting systems, and that is, I don't know if you remember, but I said when it comes to judging how much power each voter has, there's actually 2 different ways to do it, and one is the Shapley-Shubik. There is another power index, and that's what we're going to discuss today. Unfortunately, it's just named after another person, and you just have to remember which is which. But it's called the Banzhaf Power Index. The Banzhaf. This is named after, this guy Banzhaf. All right? And this is yet another way of measuring power in a weighted voting system. So another measure of power in weighted voting. And it's different from the Shapley-Shubik. You actually get a different answer from the Shapley-Shubik, although they are not really inconsistent with one another. It's just because they are measuring power in a different way. This is another measure of power, and it measures in a different way. So the answers are or might be. They're usually different from the Shapley-Shubik. All right, they're just two different ways to do it. This actually is the case in most mathematics that's used in the real world. There's not just one way to do it. There are a few different ways that you could use math to solve, a particular problem in the real world, and it's not like one is the right way and the other is the wrong way. It's just there's different ways to do it. It measures power in a different way. So let's talk about the Banzhaf. Actually, I had a fun little historical story about the origins of the Banzhaf. I think that this is interesting. Banzhaf actually is not a mathematician. I believe the man, Banzhaf, is still alive today, I think. Anyway, Banzhaf was not a mathematician. He was a lawyer and sort of a local community activist or something. I don't think he was much of an activist, but he created the Banzhaf Power Index because he sued the state of New York because he thought that something or other was unfair to him. So I want to explain to you the original scenario which Banzhaf was trying to address by inventing this Banzhaf Power Index. So this guy Banzhaf was a lawyer, and he lived in Nassau County, like Long Island. Anybody from Nassau County? Yeah, represent. I'm not, but yeah. So Nassau County, when they would vote, like they have apparently. Do you know anything about Nassau County politics? No, I don't really either. But apparently they have like local elections and people. There's like a bunch of representatives just for the county that vote on like county laws or whatever. And the way
She knew that.
you knew that? Okay, great. Do you know who your representative is? Where you live? No.
Unfortunately, I don't.
Anyway, there at the time that Banzhaf was doing this business, I believe this happened in the 1960s and 70s. At the time, there were 6 different weighted voting districts in Nassau County. And the different districts were weighted according to the population. So these are each like individual towns. And when they want to decide something as a whole county, each of the individual towns votes on it. And then they add up the votes based on the populations from the different towns. So there are 6 weighted districts, and here they are. One is Hempstead. This is the biggest town. And actually Hempstead is so big that it was divided into 2 separate districts. So there's Hempstead.
That's the town next to me.
Next to you, all right. There were 2 districts from Hempstead. Hempstead District 1 and Hempstead number 2. Are you speaking for her?
Well, no, that's
No.
the town next to me. I don't like it.
Oh, you're also there. Okay. I thought so you're
No, we're both from them.
all right. I thought
We're
only
cousins.
okay. Nice.
We like live.
But you don't live in the same town? No, certainly not. Anyway, there's Hempstead District 1 and then Hempstead District 2. This is the biggest town, and so they divide it into 2 districts. And those districts each had 31 votes, right? In terms of once everybody in the town votes to decide what the town vote is. And then that counts for 31 of the votes when they add them all up. All right, and then there was North Hempstead, which is different, apparently. North Hempstead, which had 28. And then there was Oyster Bay. You've heard of these places?
I live in Oyster Bay.
Nice. I hear they get 21 votes in the county elections. There is also, and then there's 2 little ones. There's Glen Cove for 2 and Long Beach for 2.
That's next to my summer house.
Okay. So which one do you actually live in? None of these?
No, I live in Garden City.
Garden City.
Yeah.
All right.
I love it there.
Okay. I don't know anything about these places. I hear Garden City is nice, though,
It's beautiful.
from you. So these are the votes. How they this I believe it's not divided in this way anymore. This is like in the 70s when Banzhaf was doing his thing. All right. And the way it works is when something needs to be decided, each town votes individually, and then whoever wins it, like per town, these numbers are added together. So this is a big weighted voting system. All right. And you need 58 votes to pass a new law or whatever it is they're trying to do when they have these votes. All right, you need 58 is just a majority of, if you add all those numbers up, 58 is one more than half of that. All right. Now, Banzhaf, living in this scenario, Banzhaf, I believe, lived in one of the little ones. Let's say Banzhaf lived in Glen Cove. All right. Looking at these numbers here, Banzhaf realized, actually, to get to 58, Glen Cove and Long Beach are dummies in this system. That's because this vote of 2, the people in Glen Cove, like they can vote, and those 2 get to count for whatever they voted for. But actually, if you want to get to 58, there's no way that these 2 can have any effect on anything. All right? Because in this weighted system, this 2 and also this 2 would constitute dummies, all right? And actually, if you look carefully at the numbers, this is less obvious, but also the 21 is a dummy in here. There's actually, if you think about all the ways these numbers could add together, there's no scenario in which the 21 actually matters, all right? The only ones that matter are these 3 up here. So this was Banzhaf's big realization. Banzhaf realized that the 21, the 2, and the 2 are all dummies. All right? This really happened. What that means is, like, everybody in Oyster Bay, they could feel good about themselves by going out to vote, but actually their vote has no effect on anything. It cannot, even in theory, it can never influence the impact of the election. All right? This obviously is not okay in terms of representative democracy. So in this case, actually, if you look at all these populations here, actually in this case, about 22% of the population, that is all the people who live in Oyster Bay and Glen Cove and Long Beach, 22% of the people had no possible voting power, right? They could vote, but there's no mathematical way that their vote would ever matter for anything. And this is not okay, right? And so Banzhaf lived in one of these dummy districts and realized the system is unfair. Like, it makes it so that all of these, a huge amount of people, actually, they can vote if they want to, but their vote doesn't actually count for anything. And so he, being a lawyer, decided to sue the state of New York. And eventually there were many lawsuits related to this, but in order to sue the state, Banzhaf invented this power index to prove that he was, here's a big word, disenfranchised. Disenfranchised means he was, well, the standard meaning of that is that just somebody who is not allowed to vote for some reason. But technically speaking, these people were allowed to vote. It's just that their vote, like, mathematically, had no impact on anything. And so that is equivalent to being disenfranchised. That is, their votes didn't matter at all. All right? And Banzhaf wanted to argue this in, like, official court cases in front of judges. And so he invented this mathematical way of proving who has what amount of power in a system like this. All right. Eventually, the impact of this is this took a long time to work through, but in 1993, the New York State outlawed weighted voting. you can do it with your friends in your basement, but there are no state elections in the state of New York which use weighted voting for this reason, because it at least allows for the potential of some dummy districts, which is never okay in a representative democracy. So there, all of these, like these numbers that I wrote up here, they don't do this anymore because it's unfair to a lot of people, all the people in Oyster Bay, Glen Cove, and Long Beach. All right. So I don't know, whatever they do in Nassau County right now is not that. I think their solution was just when all the people vote, they just actually count up individual people's votes, and that is fair, rather than doing this thing where you clump them into groups and then give points based on the groups. They don't do that anymore. It has been outlawed. All right. Anyway, let's talk about Banzhaf's big idea. So he had to look at these numbers and somehow find a way of scoring how much power each of them actually has. Now, you could use the Shapley-Shubik to do that, but I don't think the Shapley-Shubik had been invented yet. This is in the 60s that Banzhaf came up with this idea. Or maybe he just didn't know about the Shapley-Shubik, because most people don't know about the Shapley-Shubik. Anyway, how did Banzhaf do it? Let's talk about the details here. This is the Banzhaf. How to do it. It's not like the Shapley-Shubik. The Shapley-Shubik is about writing down all possible orderings of the candidates. We don't consider different orderings of the candidates. The Shapley-Shubik, you consider all possible combinations of candidates. Or I'll say, I don't mean candidates, I mean voters. All possible combinations of voters who might vote sort of yes together. All right, and here, let's just do a little example here. So let's say I have 16, 12, 10, and 5. As usual, I'm going to call them A, B, C. The first number there is the quota. We are going to consider all possible combinations of voters. So I am, again, going to make like a big chart here where we just basically count stuff up on the chart. And just like the Shapley-Shubik, it's not really hard to do, but you have to draw the chart and make sure you don't mess it up. But yeah.
It's going to be 4 12s, 1 10, and 1 5.
I don't know what you mean.
You list out all 6 combinations.
I think there's actually 8 combinations. I think you're thinking ahead of me. Yeah, you're thinking a few steps ahead, maybe down the wrong path. I'm not sure what you're. Okay. Get back to me in a minute and see if this is what you were expecting me to say. So the different combinations of the ways that the voters could get together. So there are, like I said, I gave it away, a spoiler. There are 8 different combinations of different voters who could vote together. One is you could have all 3 of them together. So I'm going to write all 3 of them, A, B, and C. They could all vote yes together. All right. Now, when I write these combinations, I don't care about the ordering. So I'm always just going to write them sort of in alphabetical order. You could also have only 2 of them, but not the other one. And there's a few ways you could do that. You could have just the first 2, but not the last one. You could have just the first one and the last one. So you could have A and B, or you could have A and C. I'm trying to leave gaps here just so that I can keep straight which ones I'm talking about. Or you could have just B and C. All right. I'm trying to think of all the different ways that you could make groupings, different combinations of these voters. All right. They could be all 3 together. They could be 2 together and the one is not with them. Or it could be just like one person and not the other 2. So it could be just A by themselves, just B by themselves, just C by themselves. And then there is sort of a technicality combination, which usually ends up being irrelevant when you're actually doing the Banzhaf, but for mathematical completeness reasons, there is the combination consisting of nobody. If everybody is against, nobody is voting yes, I'm going to write that as like one of these guys. So that represents nobody. All right. These are all the different ways that the voters could vote in combinations. Sometimes these are called coalitions. I think Banzhaf himself referred to these as coalitions. All right. And so the next sort of column in the chart here, I'm just going to add up the total weight here to see some of these combinations don't even make it to the quota, and those ones we don't really care about. The ones that we care about are the ones that actually reach the quota. So in the first combination, ABC, I'm just going to add up the weight of this. This would be 12 plus 10 plus 5 is 27. So that one does make it to the quota. The next one, A and B, would be 12 plus 10. That's 22. A and C is 12 plus 5, which is 17. B and C is 10 plus 5, which is 15. I hope everybody sees what I'm doing here. You just add up the numbers according to which combination you're talking about. A all by themselves is 12. B by themselves is 10. C by themselves is 5. And nobody is 0. All right? These are the weights of the combinations. And like I said, we only really care about the ones that actually make it to the quota. So we only consider the combos which reach the quota. So in this example, I don't care about anything below here, right? These guys down here don't matter. You have to list them out just to make sure that they don't matter, but we can see in this example the quota is 16, and I only care about the ones that actually made it to 16, and so we don't consider those ones down there. All right, and now comes the interesting part. We are going to decide in each line here, just like, remember the Shapley-Shubik? In each line you decide who is pivotal. It's a similar thing here, although it's not called pivotal because this is a different system. It's called critical for the Banzhaf. I don't know if this is confusing, the different terminology, but in each combination, we decide who is a critical voter. We decide who is critical. And this will take a bit of explaining to talk about like what actually does it mean to be critical. It's not the same as pivotal in the Shapley-Shubik, which is about adding them up in order, because these we don't consider the order to be important in these. So I don't think about this as like A, then B, then C. It's just all three of them together. Anyway, let's talk about what critical means. We'll come back to this example. I want to talk for a bit just to make sure everybody is clear on what critical means. So critical, here's the definition. A voter is critical in some combination if their vote was necessary in order to meet the quota. They are critical if their vote was necessary in order to meet the quota, all right? One way to think about it is you ask yourself, like I said, we are only considering the combinations which actually make it to the quota. And so you can think about, is this voter critical? It means, did I really need this one to make it to the quota? Or if I remove them, would it still reach the quota? That's one way to think about it. So here is a simple example in that chart up there. A, B, C, the total was 27. Who is critical? Remember the system was, what was it? 16, 12, 10, 5. All right. In this case, the total is 27. I want to ask myself, of these three, which of those really is necessary in order to make it to 27? For instance, is the C critical? You got to ask yourself, when I add these up, I get 27. Did I really need the 5 to make it to 16? The answer is no. So the C is not critical here. So in this combination, who is critical? C is not. This is because without C, A and B still makes it to the quota. All right?
So it's the same as saying a voter has veto power.
It is kind of like that. Yeah. Veto power means it's not exactly the same. When you say veto power, it means in the entire system, they always are necessary in order to make it. Here we're talking about just in the context of this combination, which one of them is necessary in order to make it. Actually, since this combination is everybody, it's the same as veto power. All right, so C is not critical. What about B? In this combination, do you really need the B to make it to the quota? In this combination, it's 27. If I took away the B, that would drop it down to 17, which I think is still meeting the quota. So that means B also is not critical. B is not critical. For the same reason, without B, A and B, the other two will still make it to the quota, all right? Without the B, it's only 17, but 17 still counts as meeting the quota. What about A? I think A is critical. A is critical here. That's because without A, B and C makes only 15, which isn't enough. All right, so in that particular combination, only A is critical, and the other two are not. All right. What about one of these other combinations? How about in just AB? AB, which added up to 22. Who is critical? Remember the system was 16. I forgot again. 12, 10, 5. All right, this time I consider only A and B. They make 22. Is A critical there? That means if is the A actually necessary in order to make it to 16, just between A and B? I would say yes, the A is necessary. If I took the A away, this would drop down to 10, which is not enough. So here, A is critical. And what about the B? Also, the B is critical. So it can be more than one is critical. B is also critical. All right. What about in A and C, which makes 17? Are they both critical? One, not the other, or neither? I think the answer is they are both critical in this case also. A and C, 12 and 5 add up to 17. If you got rid of either one, it would no longer make it to the quota, which is 16. So here, A and C are both critical. This is a little harder, in my opinion, than figuring out the pivotal from the Shapley-Shubik, and you have to get used to figuring out who is a critical voter in each line. Weird papers. All right. I thought it might be fun to look at something like a real-world example. I have a real example on a handout here. I know people love handouts, especially those liberals, am I right? This is about the Electoral College, which of course is a weighted voting system with many different voters. Here I have the, what?
Is that a joke I'm not privy to?
What?
The handouts.
The handouts? Yeah, they always say the liberals love handouts. Always trying.
Thank you.
That's the joke. You don't have to like it.
I don't know what the punchline is. It's not your fault.
Thank you. I'm not too worried about it. I got distracted. Yeah. Handouts in American politics. That's what they call. That's what people who hate the poor say when someone's trying to help the poor. They're like, "Nah, you can't just give people handouts." They're dying in the street. What are you going to do? Give them money? Come on. And the liberals say, yes, we're going to give them money. That's a bad thing in American politics to some people. Anyway, let's look at, so can we look at the side with more stuff on it? 2016 and 2020 presidential election. So on the left side is the 2016 Electoral College results, and on the right side is the 2020, the Trump versus Biden. So in, let's look at in 2016, this is Trump versus Clinton, right? Now, you can consider all of the states which voted, so the winner was Trump, right? Trump was the winner. And all of the states which voted for Trump, we can think of that as like one of these combinations, which apparently did make it to the quota, right? All of those states together makes it to the quota. In this case, you can see at the very bottom, it says the Trump total was 306. How much you need to win is 270. That's how the Electoral College works. And so Trump was the winner. I would like to know, among all the states that Trump won, so Trump's states altogether are a combination. And within those, which are critical? You have to look carefully at the numbers, I suppose. But which of those states is critical in this combination? That means, if any, which of them did he actually need to win? Because you can see Trump got like extra points, right? You need 270, but he overshot it. So he didn't actually need all of the, like for instance, Trump won Alaska, which was 3 points, but that was not critical in that combination because he didn't actually need those 3 points. Are any of those actually critical for Trump? Can you say, if you look at the numbers there, are there any of those states that he really actually did need? Yeah.
Texas?
Yeah, I think Texas is the only one which was critical in this election for Trump. Because if Trump had, if Trump had lost Texas, then he would no longer have the enough electoral votes to make it to 270. So in this example,
What about Florida?
Florida.
Past the line or no?
I see Florida has 29. If you do 306, if you were to take away 29, he would still be making it, I think, if you do the numbers. Yeah.
But how do you know, like, if, for example, like, yes, Texas is the highest number, but, for example, Florida or Pennsylvania, how they're not? Like,
Yeah, so you would just think about, what about Florida? I mean, you can work out the numbers. If you think, what would happen if Trump lost Florida? You would do 306 minus 29, and that still
okay.
makes it
Yeah.
to the quota. Yeah. So you think about each state individually. Which are critical? The answer is only Texas is critical here. All right. Florida is not, because if everything else was the same, Trump could have afforded to lose Florida, and he still would have won. All right, that's what critical means in this case. Can we look at the other side, Trump versus Biden? Trump used to say, he loved saying, we had one of the biggest electoral college victories ever, which is just straight up not true. I don't know why he says that. It's not at all true. Like Biden's victory was basically the same as Trump's, and many other people. I think one of the biggest victories ever in recent times was like Ronald Reagan. I think only lost one state or two states.
Yeah.
That was a true blowout.
Yeah, he only lost Illinois.
Yeah, Trump won, but it was not a landslide. I don't know why he says that. Anyway, let's look at in 2020. So this time Biden was the winner. I would like to know which states for Biden are critical, if any, for Sleepy Joe. Your eye should be drawn to California, right? That's the biggest one. So is California actually critical? The way you would figure that out is by taking Biden's total is 306, subtract out the California, and see if that causes it to go below the quota. And it does. If you remove California from Biden's total, it goes down below 270, right? And so the answer here is California is critical. Any others? You should next look at like the next one down. I suppose is New York. So is New York critical? The answer is no, it's not. Because if I subtract away 29 from Biden's total, that would still be in the winning range, 270. All right. So California is critical, no others. All right. This is what it means to be critical in a particular combination. All right. Any thoughts about that? Can we look at the other side? This is just an interesting example. This is the year 2000 presidential election. This was the Bush-Gore election. What you see at the bottom there, this is a close electoral college result. You can see Bush got 271. You need 270 to win. So in 2000, Bush won. Which states are critical for Bush? The answer is all of the Bush states were critical for Bush in that election. Which states are critical for Bush? And the answer is all Bush states, not the other ones, just ones that Bush won. All of them are critical. Even the itty-bitty ones, all Bush states were critical, all right? By the way, this example demonstrates that there is no dummy state in the Electoral College. Even the very small states can, in theory, matter when it comes to adding up the votes, because it is possible to just win by one. You can win the Electoral College by one. All right. Any thoughts about that? This is just a little fun real world example I thought is interesting to look at the numbers in the real world every so often. All right. In this case, all of the states were critical. This almost never happens. Usually the president wins with some room to spare, right? Like Trump and Biden and Obama also. But in this case, there was no room to spare for Bush. All right. Let's get back to our example that we had started last time. So let's really do the whole example, and then I have one for you all to try. So let's try to finish. This was my example: 16, 12, 10, and 5. All right. I call these ABC as always. So we write down. We already did most of this. I'm going to write down the combinations, right? So there is all three together, and then there are two but not one in three different ways. And then there is one but not the other two, again in three different ways. The A here, the B here, the C here, and then there's the nobody. All right? But, and then we add up the totals. This we did before. It was 27 here. It was 22, 17. I'm just copying what I had before. 15, 12, 10, 5, and 0. And we decided that these guys here don't matter. You only consider the ones that actually make it to the quota. And then each time you decide who is critical. Now, it's not like in each row you might have more than one being critical. It's not like you just pick one critical each time. So my chart is going to look like this. I'm going to decide in each case, is A critical or not? And then is B critical or not? So in the first line, we decided when we thought this through before that A is critical, but B and C are not. So I'm going to indicate that by doing this. This means A is critical. That's because in A, B, C, A has 12 votes. And if you took away the 12 here, it would go down to 15, which is not meeting the quota anymore. So A is critical, but B and C are not. In the next one, A and B for 22, we decided that both A and B are critical in that case. This is one of the examples we did before. So, all right, check them both off there. And then in A and C, again, we decided both of them are critical. If you have only A and C, then you need both of them in order to still reach 16. So A is critical and C is critical. All right. This is all the work is done at this point for the Banzhaf. So the hard step is what we just did right here, is deciding in each row who is the critical voters and who is not. All right. The final answer is just like the Shapley-Shubik. We just sort of count everything up here. And so the way that we do this for the Banzhaf, my final answer is a bunch of fractions, just like the Shapley-Shubik. The way the fraction works is A is critical 3 times, so that's the numerator. Out of how many? The denominator is going to be the total number of checks that you see. So there are 5 total check marks here, and 3 of them are A's. So the total for A is 3 out of 5. The total for B is 1 out of 5. And for C is 1 out of 5. And that's the final answer. And as usual, you can write this as a percentage if you want to, although I won't expect you to on the, sorry, 1/5 is 20%, I happen to know. So this is 60%, this is 10%. Huh? 20. 1/5 is 20. And this is 20%. All right? On our tests, I would not expect you to convert to a percentage. So maybe I said this, but I'll just get it down in writing. Each fraction is, the numerator is the number of times that whoever it is critical. And then the bottom is the total number of critical, check marks on the chart. So there were 5 total checks on my chart, which is why all the denominators there are 5s. All right. Can I just say one thing which I thought was a little weird on the tests as I was reading the tests about the Shapley-Shubik? Like I said, most people did this correctly, although some people did something which I would describe as socially awkward. Some people wrote the answer like this, and then they were like, hey, A wins because they got the most. This I would describe as not properly reading the room. The point of the Shapley-Shubik or the Banzhaf is not to declare somebody as the winner. It's meant to be a measurement of how powerful each of them is. So what this means is that in this system, A has 60% of the power, B has 20%, and C has 20%. So that doesn't mean A is the winner. I mean, it just means they have more power than the others, which you already knew that by looking at the numbers. So this is, you can say that, I guess, but that's not the point of these systems.
Would you mark them wrong if they did that?
Yeah, I didn't mark it wrong when you did that, but I want to be like the there's some meme of like Jonah Hill at the Oscars. He's like, no. Like that's what I say when somebody does that. Like you shouldn't say that. I mean, I know what you mean and it's wrong. Like you did the whole problem right, and then you did this silly thing at the end, which you shouldn't have done. All right. So don't say A wins. They have the most power. They have the highest Banzhaf number, but that doesn't make them win in any ordinary sense. It's like doing the Electoral College and saying California wins because they have the most. I mean, yeah, they have the most. They don't win though. They have the most. All right. Can I just say, like I said, I have an example for you all to try. Actually, let's just do that. So I would like you to try. I'm going to walk around and see how you feel about it. Find the Banzhaf for this voting system. 10, 6, 4, and 3. All right. See what you think. I'll give you a few minutes. I'll walk around and see how you're doing. You got to make the big chart and then decide who is critical. Feel free to talk to your friends. You got any? Okay. Yes, looks good. Okay. Yes. Yeah.
He's looking for you.
Yeah, only one second. Good? Looks like people are doing good with these. I'm gonna write it up here. My answer. All right, so I hope you got, this much of the chart is straightforward, right? The interesting part comes when you decide who is critical in each line. So the first line here, A, B, C adds up to 13. You got to ask yourself, is the A really necessary here? If I were to take the A away, it would go down by 6, which is 7, right? If I take the A away, it goes down to 7, which no longer makes it to 10. So this A is critical right there. I think pretty much everybody said that as I was walking around. B also is critical because if I took away 4, then this goes down to 9, which is not enough anymore. So B also is critical. But the C is not. That's because the total is 13. If I give up 3, I still make it to 10, which still makes it to the quota. So the C is not critical, so I'm not going to put a check right there. I hope everybody sees how that you have to think this through. It's not like the other one. I would say this is not really hard. It's just you have to make sure that you are concentrating, and it is kind of easy to mess it up. Anyway, in A and B together makes it to 10, but if you gave up either of those, it wouldn't make it to 10 anymore. If you give away the 6, then you don't make it to the quota, and if you give away the 4, then you don't make it to the quota. So that means A and B are both critical. And these are all the check marks. C is never critical. Actually, that's because if you think about it, C is a dummy in this system here. All right, anyway, my final answer is A gets 2 out of 4. That's because there are 4 checks total, and 2 of them are A's. B gets 2 out of 4, and C is 0. Percentages for this one are easy. It would be 50, 50, and 0. All right. Anybody got thoughts about that? All right. let's talk a little bit about the combinations. I would like to talk about how many combinations will there be. In the case of 3 voters, A, B, C, if you list the entire list, you will notice there are 8 of them here. So I want to just think about how exactly would you know how many combinations to expect. How many combos will there be? Let's imagine instead of 3, well, can I just say for A, B, C, there's 8, right? What about for 4 of them, A, B, C, D? How would I think about how many combinations there can be? Now, we talked briefly about this for permutations. The permutations meaning all the different ways to put them in a different order. And I thought about that in terms of like if you had like 4 slots and you had to choose alternatives for this one and then this one and then this one and this one. If you are putting them in some order, you have 4 choices for the first slot and then 3 for this one and then 2 for this one and then only 1 choice for this one. And you would multiply those all together. You get 4 times 3 times 2 times 1, whatever that is. What about this, though? This is not about putting them in a different order. This is about filling in the slots. I would say in this case, they don't go in some order. It's just like each spot. This one is either A or no A, right? And the next one is either a B or not a B. Because the combinations, the way they work is, so these are scribbled on, but you can see, the first one is either A or there's nothing, right? Or the second one is either B or nothing. So those are the choices we have for each of these 4 spots. This is A or no A. The next one would be a B or nothing, right? Etc. In this case, I would say actually you just have 2 choices per slot, right? Is it there or is it not there each time? And so what we have here is 2 choices, 2 choices, 2 choices, 2 choices. That would be, how many possibilities would be 2 times 2 times 2 times 2, which is 16. So I will say each slot has 2 possibilities. Because each one is either yes or no. Is the A in there or not? Or is the B in there or not? And so the total number of options is 2 times 2 times 2 times 2. All right? Of course, this would be more typically written as 2 to the power 4. I hope you remember what that means. The power just means you multiply that number by itself 4 times. All right? So this is the total number of options. And this is easy to see in general. For n voters, if you have many of them, there are 2 to the power n different combinations. All right. So this is how you know that when there's 3, for instance, you get 8 different combinations because 2 to the power 3 is 8. And when there are 4 combinations, or when there are 4 voters, you get 16 different combinations. That's 2 times 2 times 2 times 2. All right. This number is pretty big for a large. If you wanted to do this for the Electoral College, this is kind of too big. It would be 2 to the power 50 or 51 if you count DC, which is a very, very big number. You could probably handle that using a computer, but you would never be able to do that by hand. All right. So I thought we should, just as a final remark or a final, we got plenty of time. Let's try to do one example of the Banzhaf with 4 different voters. Maybe I'll go to my new page here. Let's try Banzhaf for a big one, a big boy. 5, 4, 3, and 1. All right. We're going to write down the combinations, and we expect there to be 16 of them. That's kind of a lot. I mean, it's not completely unreasonable. I would say this is at the upper limit of what I would expect you to do on a test. I might ask you to do one like this. I would never go to 5. 5 options would have 32 different combinations, which is just silly in my opinion. All right. Anyway, there are A, B, C, D. So I'm going to try to write the combos. I'm going to try and think of them in the same way in terms of like groups. So the top combination would be everybody is all in, right? So that would be A, B, C, and D. Everybody in. All right. Next, I'm going to list out the combinations which have all of them except for one missing. And those are fairly easy to write down. It would be A, B, C without the D. Or I could go A, B, D without the C. Or I could go A, C, D, that's without the B. Or I could go B, C, D without the A. You guys good over there? Don't nudge her. It's your fault too. All right, so those are all the ones which omit one of them. Now I can list down all the ones which have 2 and are missing 2. This is a little more tricky, but it would be A, B without the other 2, or I could go A, C, or I could go A, D. All right, those are all the ones which have A and are missing 2 others. Or it could be B, C, or B, D, or it could be C, D. I'm off the screen, off the heezy. All right. So those are all the ones with only 2 in, 2 out, and now we're almost done with this. There's combinations which have only one of them. So there's just A, just B, just C, just D, and then finally nobody. If you count this up, there should be 16 of them total. All right. That's the setup. Okay, can we finish it off? So we need to write down the totals, right? The total weight in each category. So this involves just, adding up the numbers. This is not hard to do. It's a bit of a pain because there's so many of them, but I wouldn't say it's really difficult. So the total for the first one, A plus B, this is 5 plus 4 plus 3 plus 1, that's 13. The next total is 5 and 4 and 3 is 12. The next one is 5 and 4 and 1, that's 10. Next I have 5 and 3 and 1, that's 9. Next I have 4 and 3 and 1, that's 8. Then I have A and B, that's 5 and 4 is 9. A and C would be 5 and 3 is 8. B and C would be 4 and 3 is 7. Actually, at this point, I think that I don't really need to consider the other ones. Remember, we only consider the ones which actually make it to the quota, which is 8. I believe none of the other ones are going to make it to 8. B and D would be 5. C and D would be 4. All right, the rest are all below 8. So really, these ones do not need to be considered.
Why is A and D 8 and not 6?
It should be 6. Yeah, thank you. Oh, and did I skip A and C? Oh, yeah, I lined it up wrong. I meant the 8 should be there, right? Sorry. They were all. This is a 9. That's a 8. And now the rest are less. I had them off by 1 position. Thanks. All right, so from here, I don't really need to consider those ones. I can zoom back in. All right, and now in each row, we need to decide who is critical and who is not critical. So my choices are, A, B, C, or D. Are they critical or not? The crits. The quota is 8, all right? So in the first one, is anybody critical? You should start with the biggest one. Is the 5 critical here? That means, is the 5 actually necessary to make it to the quota? What do you say? Got thumbs? Anybody? I see some thumbs down. Yeah, the A is not critical here. That's because they made it to 13. Did they really need 5? Well, if you take away 5, it's still 8, which is still making it to the quota. So actually, nobody is critical in this row. There will be no checks in that row because even the A, which is the most, was not critical. And so neither is the B, C, or D. All right. How about the next line in ABC? They add up to 12. if I took away the A, it would only go to 7, which is not going to make it. So the A is critical in the second line. You're always going to think about what would happen if I took this one away, would it still make it to the quota? And in the case of A here, if you took the A away, it would not make it to the quota, which means the A really was necessary in that line. What about the B there? B is worth 4. It added up to 12. If I took away 4, it would go down to 8. But 8 is still meeting the quota, and so the B is not critical in that one. All right. It's kind of a lot to think through in your mind, but this is what you have to think through for every one of these. So the B is not critical here. There's no check here. And the C also not critical because the C is worth less than the B. So if you gave up the C in that case, it would go down to 9, which is still making it to the quota. All right, and we have to just continue thinking this through. What about A, B, and D for 10? Can anybody think it over? Can you tell me who is critical in that line and who is not? What do you say?
A and B is critical.
She says A and B are critical. I think I agree. They only make it to 10. If you took away 5, that would be below the quota. If you took away 4, that would be below the quota. D is only 1. If you took away 1, that's still above the quota. So D is not critical, but the other two are. So I say A and B are critical here. All right? This is how you need to think it through. What about A, C, D? The D is only worth 1. So again, in this line, the D is not critical, because if I took away 1, it would still be 8, which still makes it to the quota. But the A and the C are critical, I believe, because they are 5 and 3. If you take those away from here, it goes below the quota. So the A and the C are critical in this line. All right. Next, I have B, C, D, making it to 8. Who's critical in that one? Someone say, what do you say? Yeah, all of them. That's because they only just barely made it in the first place. If you were to give up any of these, it would go below the 8. So actually, whenever this number equals the quota, that means automatically everybody is critical in that line. So this is B, C, and D. A and B adding up to 9. They are both necessary in there. If you took away A, that would go below. And if you took away B, that would go below. So A and B are critical here. And then A and C adding up to 8. Again, they are both critical because they add up to the quota exactly. And that's the end, right? These are all the check marks that you need to do. Now, you can probably predict. It's actually very easy to mess this up. Even if you know what you're doing, you are likely to make a little mistake in there. So when I grade this on the test, especially a big one like this, I'll probably let you screw up 1 or 2 checks and still give you the credit for it. Yeah? Yeah, why is there no criticals for the first one? She says, it adds up to 13, and you have to ask yourself, for instance, for A, is A critical here or not? The question is, if I were to subtract out A, which is 5, does it still make it to the quota, which is 8? And the answer is actually yes. If you take away 5 here, then it's still going to meet the quota. So that means, like, they only need to get 8. This is serious overkill, and actually it's so much overkill that actually none of them individually was necessary to make it. Yeah, so there is no critical there. Sometimes nobody is critical. Sometimes they are all critical. Just how it works out. So anyway, can we write the final answer and be done with this? So my final answer is A gets, remember these are fractions where the numerator is just how many checks there are for A, that's 5. And the denominator is how many total checks you see on the picture, which is, I think 12, right? So this will be 5 out of 12 for A. B is 3 out of 12. C is 3 out of 12. And D is 1 out of 12. All right. So D loses. No, don't say that. D is just the weakest of them. But we already knew that anyway. This is a specification of exactly how much each of them, how much power each one has. Yeah?
On the test, are we going to give an example like this or the problem we did originally?
So I said this would be as big as it could possibly be on the test. I wouldn't give you one with 5. I think something like this is reasonable. I mean, depending on my mood that day, I might give you the smaller one or the bigger one. I don't know. I know what you would prefer, but all right. Great. Remember, the purpose of this is to give true judgment of the relationships of power. We can see here when you do the Banzhaf, the B and the C have equal power, even though they have different numbers here. That's kind of the whole point of the Banzhaf, is that it reveals the fact that actually B and C are equally powerful, even though on the surface it's not obvious, and it looks like B has more power. In fact, they are the same. All right. We got 5 minutes left. I have just one final remark about the Banzhaf, and then when we come back next time, we can start talking about something completely different. This is the end of what I wanted to say about weighted voting. I wanted to say this is very much like what I said at the very beginning about the Shapley-Shubik. What about dictators and dummies? Dict-dum in the Banzhaf. And what we're going to say, the conclusion is basically the same as in the Shapley-Shubik. So if you have a dictator, you got to ask yourself, are they going to be critical in the combinations where you see them? And the answer is a dictator is the only one who's capable of making it to the quota. That means they will always be critical. If you have a dictator, so I'll say if there is a dictator, then they are critical every time. At least every time they appear in the combination, they are going to be critical because the dictator is the only one who is capable of making it to the quota. So if you took them away, it wouldn't make the quota anymore. So if there is a dictator, they are critical every time, and nobody else is critical. Because if there is a dictator and you ask, what if I remove somebody else? Are they still going to make it? The answer is yes. Because if there was a dictator, that means nobody else matters at all. So if there is a dictator, they are critical every time, and nobody else is ever critical. So the Banzhaf, when you count up all the criticals and do the fractions and all that, the Banzhaf will say, whoever the dictator is, gets 100% in the Banzhaf, and then everybody else, the others, will get 0%. All right? Yeah.
And nobody else is?
And nobody else is, ever is what that says. Sorry about that. Nobody else is ever critical. If there is a dictator, that means they're going to be critical every time, and because it's a dictator, nobody else can ever be critical. And so the Banzhaf will end up being that. The dictator gets 100%, all others get 0%. All right, and what about dummies? Any dummy, if there is a dummy in there, they can never be critical. That's because a dummy has no power to meet the quota at all. So there actually will never be a situation where a dummy will get a little check mark. So any dummy will never be critical. So a dummy automatically has the Banzhaf equals 0%, or like the numerator of the fraction will be a 0, which makes it a 0%. All right. So if you know ahead of time that there are dictators or dummies or whatever, then actually you don't even have to make that chart. You can just say immediately what the answer is for the Banzhaf, and it's the same for the Shapley-Shubik. All right. And this is all I wanted to say about the Banzhaf and weighted voting as a whole. So that'll do it. I hope you all have a good rest of the week. I'll see you on Friday.